Well, let's get started here. Well, we are going to be talking about, we are going to be talking about the division properties associated with radicals. And it's quite simple. When we're taking the square root of a fraction here, using division, a divided by b, you're just going to break it into two parts. You're going to say, well, that's the square root of a divided by the square root of b. So here is the easiest example on the planet, and these are easy because these are really, really nice numbers. These are called perfect squares. Well, to break this one up, it's going to be the square root of 4 divided by the square root of 9, and hopefully you can see that is going to be 2/3. That's really good. Don't get your confidence too high as we progress through these little problems here. It's going to get pretty intense here momentarily. Well, in this next example here, we have the square root of 25, which is 5, and the square root of 36, which is 6. That one looks really good. That's done. That's simplified. This one is the square root of 49, which is 7, divided by the square root of 81, which is 9. Well, that one looks good too. But now we get a little problem. Because if you think about it, what is the square root of 2? Well, that's just the square root of 2. And this one here is the square root of 3. Those are not pretty numbers at all. Well, it turns out having a radical in the numerator when we try to simplify things, that's a-okay. But having a radical in the denominator turns out to be a bad thing when we try to simplify radicals. And over the next few minutes here, we're going to develop some strategies of how to get rid of this radical that's in the denominator. Once again, numerator radicals, a-okay. Denominator, bad, bad, bad. All right, let's try some examples in here. Let's take a look at this guy right here. Well, the square root of 1 is going to be 1. The square root of 100 is going to be 10. Well, 1/10 is simplified. This one in here, the square root of 36 is 6, and the square root of 100 is 10, but that's not completely simplified because if you think about it, 6/10 is 3/5. This next one in here, well, the square root of 500 is not a nice number here. That's not a perfect square, but what I haven't made mention yet is what you can do anytime you have radicals divided by more radicals. It's just like division. So if 2 goes into 12 evenly, radical 2 goes into radical 12. How many times? Well, 6 times, so it's a radical 6. And if I tried simplifying radical 6, it doesn't simplify, so that would be the answer here. Well, in this case with number 21, notice the zeros cancel, because 500 divided by 720, it's like dividing each one by 100. Dividing each one by 10 gives us 50 over 72. And if you notice, 50 divided by 72, what factors go into both of those evenly? Well, 5 does. No, not 5. 2. 2 goes into 50 25 times. And 2 goes into 72 36 times. That's what I meant to say. And so in this case, the radical 25 turns into a 5, and the radical 36 turns into a 6. And that is our answer right there. Let's try the next one. The next two are really nice numbers here. Those are perfect squares. Well, this is radical 49, which is 7. This is radical 64, which is 8. But don't forget about this guy. That's how it's hanging out in front of the radical, so it's going to hang out in front of the fraction here at the end. That's our answer. Let's try this one over here. Well, 20 divided by 405, it turns out 5 goes into both of those evenly. 5 goes into 20 4 times. 5 goes into 24 times. And 5 goes into 405 81 times. So it might be a little awkward at first dealing with these larger numbers, but both are divisible by 5 here. And when I simplify both are divisible by 5, I get these two very nice numbers. Notice radical 4 is 2, radical 81 is 9, and that's our answer. The next one in here, I'm thinking the number 3 goes into both of these evenly. Radical 27, well, 3 goes into that evenly, we got radical 9. And 3 goes into 48 16 times, so this is going to turn into 3/4. This next one in here, notice radical 2 goes into radical 18 9 times, so this is another way to say radical 9x squared. And what is that answer? That answer turns out to be, that is 3x. All right, we learned that from a previous section or two. This next one in here, well, the square root of 64 is 8, and the square root of t squared is just t, so that's our answer right there. All right, let's take a little break and do some more problems here in a moment.